In this video, I'm going to explain how to read and write parameters via, or IO-link parameters via ISDU, and this would be using Modbus TCP/IP. There are some libraries available. For example, from the Festo website, you can get libraries for codices that already do this. But what we're gonna do today, what we're gonna explain is how to do this without having those libraries and basically handling the raw data. So this is the overall topology that I have here. So you can have a PLC, as long as the PLC has Modbus TCP/IP communication capabilities, you should be okay. And then we're connected to this CPX API EP module. So this is the Ethernet IP module that can also do Modbus TCP. And then the current topology that I have here with me is I have these four IO-link master module connected to it. So that's what I'm trying to depict with this image here. And then on the third port of that module, I have this optical sensor connected to it. And this is basically an IO-link device. And what we're going to be doing today is we're going to read and write one of the parameters for this particular device. So let's get into it. So the first thing that we need to do, and I highly encourage you to get this application note. You can get this from the Festo website, and you can look it up. And the name is CPX-API A with Ethernet IP, Rockwell Systems, and others. And the reason why we're going to be using this is because towards the end, so I'm going to go all the way to the end, there is an explanation on Modbus TCP, and this is what we're going to be using. So it's actually right here. Right here on page number 72, section 12, there's a Modbus explanation, and this is what we're going to be using today. So now let's have a look at what we are going to have in Codices, which is the software that I'm going to be using today. So in Codices, I have a project running, and this is an empty project. Just has the Ethernet card inserted here, and then I have a Modbus TCP master, Modbus TCP slave. So what configuration do I have here? I just have the network interface for the PLC. Then the master is configured with defaults, and then the slave, you need to put the IP address of the slave here, and basically the IP address that's actually right here. The IP address of that slave, it's the CPX API EP. Now, within this master or this CPX API, we need to define some channels for the communication. And here is where I want to go back to this page. So in this page, you're going to see that I have some process data, and the process data, okay, so the process data is right here. And let's go up here. So this is what you will see when you're connected to the network. So as I mentioned, I have the EP module and the 4IOL. If you go to the Modbus TCP section and then you click on holding register view, here you can see the mapping for everything, right? So you're gonna see here the process data, so the outputs and the inputs. The outputs, you see that the register starts at 0 and the inputs start at 5,000. So if we go back to codices, this is what I have here. So if we look into the process data, here you're going to see that I have an offset of 1388 hex. If we open a calculator, so if we open a calculator and put it in here, 1388 hex, it's 5,000 decimal. And this is for the inputs, right? So you can see here, read registers, inputs. So let's go back to what we were seeing just a second ago, right here. So the inputs right here start at 5,000. Therefore, that's why we have that offset for the read registers over here, right? So remember 5,000. And now for the write registers, there's no offset. They basically start at 0. And you can see that there's 4 words, and there's also 4 words for the input. So 4 words for outputs and 4 words for inputs, or 4 registers, I should say. Going back to codices, that's why we have this here, so which is 5,000, and then we have 0 on the right, and a length of 4, length of 4. Now, this is not important for what I'm showing today. I just wanted to describe it because I have it configured here. But we're not going to use process data for today's explanation. The important part comes here on the read and write for AP parameters and IO-link parameters. So actually, I'm going to focus on these two here. So IO-link parameters read. If I wanted to read an IO-link parameter, what I need to do is configure these holding registers too. And where are these? So if we scroll down again in this view, we scroll all the way down, you're going to see IO-link mailbox. And it says that it starts at 34,000, right? So it's 34,000 and it goes all the way to 34,125. So let's have a look at codices. In here, in the read, we have this offset, which is what? Let's see here. This offset is 84D0, which is 34,000, right? So we're just telling it you start at 34,000, and we're actually going with the max length here available, which is 125. Okay. This doesn't interfere because actually, if we go back to this view, you see that the maximum is 34,125. Okay, so we can leave that as that. One very important thing that I found out, you must use for this, for the reading and writing, you must use separate function codes. So you must use function code 3 for reading and function code 16 for writing. I'm used to using function code 23 for process data, which is read and write multiple registers, but for some reason it doesn't work if you're using function code 23 in here with the combination of these two. I need to do further research on why not, but I found that out. So again, make sure that you're reading with function code 3 and you're writing with function code 16 when you're doing parameter transfer. Okay, so the same thing for we actually went through this, right? So 125, okay. So the same thing for the write. We're gonna do an offset of 34,000. Remember that this is in hex. And then the length, we're gonna set the max, and in this case is 123 for the write. So if I set 125, it doesn't let me, it just says the maximum is 123. So we're gonna do 123. Click OK. And now, okay, let's go online and let's have a look here. So we're online here, and if I go to mapping and I go to parameter read, I have right now, I have on the very first word, I have a value of 254. Let's not worry about that for a second, but let me show you another screen here. Okay, so let's go over to this screen now. So remember that this is the application note that I mentioned at the very beginning. So here under this application note, under the Modbus section, there's a section here that explains how to do ISDU access. And to do ISDU access, this is what you need to do. Okay, so let's replicate that. We're gonna go to codices, and we're gonna go into IO mapping right here. And then we're gonna read. Let's read a value. Oh, actually, we're gonna read, but remember that we need to send a request, and we do that through writing. So let's have a look. The 34,000, which is the very first one, and what I've been doing is I guide myself by these last digits here, so they will match the digits over here. Okay, so let's do that. The very first one, the very first word or register, it says that this is the status. So this is basically a reply. So when we're writing, we're not going to do anything with this. Let's jump to the second one. The second one, it says here that this is for, what is this? Read and write command. So we're not ready to read or write. So we're going to leave that alone for now. Now let's go to the third one, or the number 2. It says module. So since my module is number 2, remember from the image that I showed you at the beginning, the IO-link module is the number 2. So we're going to set this here, a prepared value of 2. I haven't written that value. Sorry, I was writing the number here. So for number 2, we're going to set a 2. And then, 2. And then for number 3, let's see number 3. Number 3, it says this is the channel. So I was doing channel, I said that it was the third channel, right? So let's see here, I believe it starts at 0, so let's see 0, 1, and 2. Try that. Then the next thing is the index. Okay, so now this index and sub-index, these two values, they come from the actual IO-Link device that you're going to be dealing with, okay? So let's have a look at that. I opened the IO-Link device IODD file, or documentation for the IODD file, and what we're gonna be doing here today is we're gonna be reading this parameter, which is called switching signal 1. Remember that this is an optical sensor. So switching signal 1, I believe it's basically how far the sensor is from the objective, or the object that is sensing, and that is what this value changes. So here we can see that the index is 60 or 60, and then you have a sub-index. So index 60 and sub-index 1. Default value is 1000. I already changed this value before, so let's see what we get. So let's go back to codices, and we said that the next value, so number 4, was going to be the index. Okay, so number 4 here is the index. So we're going to say what? 60, right? 60. And then the next value is an index. Sorry, sub-index. And we said that it was 1. Right? So let's do 1. And what else is missing? Here, the next thing, it says length of data. And for the length of data, it says for read always 0. So let's leave it at 0 and see what happens. Okay, so let's go back to codices, and then I'm gonna write these values. So here we go to debug and then write values, Control F7, write those values. So those values are currently there. If we look at the inputs, so parameter read, those values are already there. You see, this is the initial status that we got, which is, I think, like an error or no status or something. But we haven't sent the command to read, right? So let's do that. The command to read is what? 50. So we need to send the number 50 there with byte swap. So I'll explain that in a second. So let's send a 50 here, and let's see if we get something. So write that, and then let's go to the inputs, and we're still having an error here. Okay, so let's see why. So it's 50. Set this back to 0. Maybe I made a mistake here, which is 3, the port number. Let's try 50 again. 50. Yes, okay. So yeah, I thought, let me switch back here. You remember at one point, the channel. You remember at one point they said, I'm not sure if this is going to be 2 or 3. So it ended up being 3. So it starts from 1. In that IO-Link master module, you have 4 ports, and it starts from 1, and then 2, and 3, and 4. Okay. So since my sensor is connected to port number 3, here the channel is just 3. Okay. So what I did now is I sent to read. So I'm reading with 50, with the command 50. Again, this comes from here. So I read, and if I go back here, it replied. So the status is 0, right? What is 0? The status 0 is okay. Previously, I had 254, which was an error, right? So now I got an okay, meaning that something was read, right? So what was read? If we keep going down in codices, if we can keep going down here, we're going to see that starting from 7, from the register number 7, go back here, register number 7, we have the data. In this case, the data that we read, right? So if we go back here, we say 7. So this is the current value. So it's 50. So unfortunately, you cannot see here, but I have the sensor, and I'm going to try to measure, I'm going to try to put it against an object. I'm seeing that right now I receive a signal that the object is detected when I'm about maybe like 2 inches away from the object. That's when the signal turns on. Maybe we can see can we see the signal here? No, we cannot. Don't worry about it because I said that we were not going to go into process data, but I am seeing the signal here. So approximately, let's say 2 inches, right? So let's change this value because we read it right now, right? So let's go back to right. And here on the right, we're going to set this to 0. So we're not doing anything. And now we should get a 254, yeah, which is the error on the reply. So we're going to do a 51. Oops. We're going to do a 51, which is a write. Okay. But we need to specify what we want to write, right? And now we need to specify also the length of the data. So let's do that. The length of the data, it's going to be on register number 6, or the 6th register, I should say, here. And the length of the data depends on the parameter that you're dealing with. I believe this parameter is like 2, maybe like a word. So let's set it to 1. So, and I said that this is going to be on number 6. So let's set it to 1. Set that to 1. And then the data that I want to write is on number 7, right? Right here. It starts at number 7, register number 7. So let's do, I'm actually not sure if I'm going to be able to do, let's do, yeah, I should be able to do, I'm going to do 1000. So that's the value that I have prepared. And again, going back here, all of the values are also here, right? But I haven't executed the write. So let's do that. So now the value that I'm going to write is here, the length of the value, and let's do a 51 here. I'm actually not sure if it's the length is 2, but we'll find out soon. So 51, I try to write, and I get a response here. And I think that this is going to be an error. So let's go back and do a read. So 50, actually, let's do 0 first. And let's see, we should get a 254, yeah. And now let's do 50 to read and see what value is stored in the device. So it's still a 50. So I was right. My suspicion was right at the beginning. I think that this should be, the length should be 0. Now that I'm thinking about it, I think the value 1000 doesn't fit in just 1. So let's do 2. So this is the length, and let's do another write. Control F7. Let's look at here. Okay, so now the write was successful. I get a 0 as a response, which is okay. And let's go back here. And now let's do a read with a 50. Control F7. There's 1000. Okay, no, now let me check the sensor. I'm going to put it around the same distance, which is like 2 inches. I'm going to start moving away. Now I'm like 4 inches, 5 inches, 6 inches, 7 inches, 8 inches, 9 inches, maybe like 10 inches, and it's still detecting. So we did modify that value, and it's now set to 1000. So this is how you can read and write parameters. It's important that you utilize this document. Oh, one thing I forgot to mention. I mentioned that I was going to explain the byte swap, right? So the byte swap, it's basically this. So if you use, let's use 100 instead of 50. You're going to get the same data, but with a byte swap. So I'm going to do 100. Let's do that in codices. So codices, let's go to write, and then we're gonna do instead of 50, we're gonna do 100, and then send that. Okay, and let's see what was the reply. The reply was okay, it was 0, but look at the data. The data now says 59,395. Okay, let's have a look at that. If we open the calculator again, and if we say 59,395, and if we go to this view, let's have a look at the bytes. So here you can see we have 2 bytes from 0 to 7, right? And then from 8 to 15. These are just basically swapped. If I swap them here on the left calculator, we should get a value of 1000. So these bits, I'm going to send them to position 8 and 9. And then these bits, I'm going to send them starting from position 0, which would be this, and this, and this. And there's your value, 1000. So in other words, using the 50 helps you dealing with data that might be swapped depending on the device. Okay, so that is how you would read and write parameters utilizing Modbus TCP. The only difference, so this was for IO link. The only difference if you were doing AP parameters, so that's specifically for the CPX-AP modules, is instead of utilizing these commands, you would utilize these commands over here on the top right here. So write module number, parameter ID, parameter instance, and instead of 50 you would do 1, instead of 51 you would do 2, and so on. So that is if you wanted to read AP parameters. Okay, so I'm hoping that this was helpful for you, and I will see you in the next one.